Hi guys, my name is Gouthaman Asokan and I'll be presenting the webinar on Llama 2. Let me give a brief overview on the topics to be covered. First, we will see what is Llama 2 and how it is different from ChatGPT and its previous versions. And we will discuss about its model architectures, what are some of the different concepts they have used, particularly in this model, and we will also be seeing briefly on the reinforcement learning techniques that they have used and compare this model. This is a totally open source model compared to the previous closed source models. So what are the open source models available presently and how it is faring compared to other models. So that we'll be seeing. And finally, we will also be seeing how to run the Llama 2 and what are the options to fine tune it. So these are the things that I plan to cover in this webinar. If you guys have any doubts, as such uh, during those slides. So the first thing is Llama 2. So what is Llama 2? Llama 2 is essentially the large language models by Meta AI. So Facebook has released this Llama 2, and they have already released the version 1. So this is version 2, and here there have been many variants. Particularly, there are smaller models with 7 billion parameters and up to 70 billion parameters. There have been various variants that has been released, and particularly they have also released Llama 2 Chat. So this specifically for the dialogue use cases. And the most interesting aspect is this is completely free for the research and commercial use. So this could be integrated completely into the products we make. And one of the things they promise is this being completely open source. This will pave the way for democratizing access to the AI models, because let's take for example the ChatGPT. It's completely a closed source model, so we don't know what's happening. So here, since we ourselves have the model, we can fine tune it and make it more close to the alignment that we want compared to those things like ChatGPT. I will also briefly cover how the version 2 is different from version 1. So version 1, if you see, I'll go here, and here if you see, this is the version 2, and it has three variants basically: the 7 billion version, 13 billion version, and 70 billion version. And what it has done is it essentially has trained on 40% more data, 40% more data than the version 1, and it also has double the context length. So it being trained on a higher number of data and having a higher context in itself helps Llama 2 to make significantly higher improvements over the version 1. And the pre-training tokens that has been used is 2 trillion, and the context length that has been used is 4096. This has been only the half has been the context length in version 1. So here they have doubled it, and data collection for helpfulness and safety. So we'll be seeing how they distinguish between both these aspects. They are very keen that the chatbot should be both helpful at the same time should give a response that is very safe. So these two things they really keep in mind, and uh, they have made the architecture to be compatible for both of these aspects. And supervised fine tuning, they make it over this 1 lakh records, and human preferences again it is over these records. So how is the version 2 and version 1 compare itself to? So because it has been trained on more data and it has a higher context length, it naturally performs in all the external data benchmarks. And this is with respect to anything like reasoning, coding, proficiency, knowledge test. So any of these benchmarks that we usually test the chatbots with, this has been performing better than the previous version. And specifically, this has used the RL from human feedback that has been widely used in these kinds of large language models. And most importantly, it provides this privacy and offline accessibility, which we don't get with many of the closed source models. And this is a major boost because let's take, for example, we need the data privacy to be one of the key aspects in our product, or we have a limited internet access. Product just has some challenge of limited internet access. This model could prove to be a huge boon. And as far as model sizes are concerned, the Llama, the version 1 was released in 7 billion parameters, 13 billion, 33 billion, and 65 billion parameters. Llama 2 has been released in 7 billion, 13 billion, but there has been no 33 billion parameter variant that has been released. But instead of this 65 billion, they directly go to this 70 billion parameter model. These are the major aspects in which the version 1 and version 2 are different.
So Gouthaman, I have one question here.
Hi.
So what is the minimum specs like, or the recommended specs required to run it on the local system?
Local system, I think the T4 GPU, right? I tried it in Collab actually. With the T4 GPU, it's compatible. This is running the model, fine tuning the model. Even the T4 GPU is not enough.
No, I'm just running the model. Not definitely the compiling. It will be take more resources, but for just running, what will be the minimum configuration that will be required?
Yeah, I'll show in the Collab. So essentially in Collab, it's T4 GPU.
So basically, we have a client called Freedom GPT. I have shared the link. So if you go to that link, you will find what we call as a downloadable, GPT. It's Llama 2 only. And for Windows, it needs 16 GB RAM and 250 MB hard drive. And for Mac, M1, M2 Max only, it needs 16 GB RAM and 255 MB hard drive. So we do have a downloadable Llama 2 for our client, which is Freedom GPT. So check it out. It's very interesting. I hope that answers the question.
Yeah, it does. Thank you.
Yeah, it should be working fine with 16 GB. Fine tuning, I'll again come to that part later. So two of the interesting things that they have used in training this LLM model is first this group query attention. So essentially, what we see in transformers and any of the NLP models is we have this key query and values, and this gets trained for each of the individual entity. But here, what happens is Llama 2 uses this group query attention. So here, if you see the group query attention, instead of taking a single query, it takes the neighboring tokens also in producing the results. So here, if you see, instead of this individual queries, it takes the neighboring tokens, and for that a particular key and the value. So this has been made so that the speed becomes a major boost, because there has been a because we use a lot more less parameters, right? Because here we use individual, and here we use for a combination of neighboring tokens a single query. So that is something that they have used in Llama 2. The next thing that they have used is rotative.
Could you briefly repeat the previous slide? I couldn't understand it.
Yeah. So here, what happens is, like in your transformers, you usually use individual query key values, and here this particular Llama 2, what they use is they use a combination of neighboring tokens. For example, a sentence starts and they use the first two words of that sentence as a single query, the next two words as a single query. So in this way, they have structured the neighboring tokens as a single entity and make that as a query, and for that they make the key. So in this case, if you see, there is 3, 6, 8. There are around 8 queries here, but here if you see, it's just 4 queries in the group query. So in this way, what they do is they reduce the number of parameters to be trained, and this in turn helps in faster speed in training. Wait, is it clear?
Yeah, thanks.
The next thing is the rotational position embeddings. The embeddings that is being used in transformers is what they do usually is they make the positional encodings for each of the letters, and this is being done through this sine cosine entities, and that they add with the context embeddings and send it to the model. But here, interestingly, what they use is they use this rotational positional embeddings, where based on the position that they find it to be. For example, the position could be 1, 2, 3, 4, 5, 6. In this position, based on this, they rotate the embedding, the context embedding, and the resultant embedding that they get, that they send it to the model. So this is the main idea between of the rotatory positional embeddings.
Can you repeat?
Yeah. So what we have is like we have the positional embeddings in usual cases in the transformers and ChatGPT. What they use is they have these positions, and for each of these positions, they get the position through the sine and cos variance, and that whatever they get, they add it with the context embeddings and send it to the model. Here they don't add those positional embeddings. What they do is for each of the position, they find an angle. So related to each position, they find an angle, and what is the context they get for each of this token? That embedding they rotate with respect to the position. So let's take for example, there is a token for let's take for example, there is this formulation. Let's take for example the formulation. So for formulation, there will be a embedding for the words. For example, if we have this formulation, the first token would have some embedding. In usual case, what we do is this is 1. So for that 1, what is the positional encoding that we get? That we will add to it, and we will get the final embedding x1. Let's take for example, this is x1. And we send this to the model. Here, what we do is, for 1, there is an angle that has been calculated, and accordingly, it's been rotated. This x is being rotated based on the position it has been, and then we get this x2. So this is being sent into the model.
Why rotate?
And this is like they find this to be very efficient than the other things.
So rotate by what degree though? How do they?
The rotation is based on the position actually. So if it is like for example, based on the positions, it changes the rotation. So it will be different for 1, it will be different for 2, 3. Based on all those positions, it will be a different rotation angle.
So somehow it has better position dependency represented in new location.
Yes, yeah.
Okay.
So this is one of the interesting things that they do, because all the models, what they usually do is they add the positional embeddings and then send it to the model. Here they are using this rotatory positional embedding.
There was a question on chat.
Yeah.
If you check the chat, there is a question there by Rakshi Rocky.
Just a minute. Okay, use cases scenarios where Llama 2 outperforms Llama 1. I'll show the benchmarks actually. So it usually the Llama 2 outperforms Llama 1 in almost all cases, because as we saw, it has a better context length. It has been trained on more data. So just for these two reasons, it usually outperforms Llama 1, and it doesn't give that much good results as ChatGPT, but it's the leading model when we compare just the open source model. Hope this answers, and I'll also show the benchmarks between the Llama 2 and Llama 1. The next thing that we'll be seeing is how do we train the Llama 2 chat. So Llama 2 chat, before going to the Llama 2 chat, could anybody tell how is ChatGPT being trained? What are the three major steps in it?
Anybody? So there is RLHF, but that's human in the loop feedback. But and before that is transformer neural network on internet data set.
Yeah. So essentially, what we do is self-supervised learning and the unsupervised learning. So we first do this unsupervised learning and supervised fine-tuning, and the third step is this reinforcement learning from human feedback. So these are the three steps that is being used in ChatGPT. And essentially, Llama 2 also uses the same steps. So here, if you see this self-supervised learning, so this is the first step they undergo. The second step they undergo is the supervised fine-tuning, and the reinforcement learning part is this part. So they go through all these three phases. So the only major difference it has with ChatGPT is it uses these two particular ideas. It has separate models for the safety, and it has separate model for helpfulness. So this is the first part that makes it significantly different from ChatGPT. And the second thing is this rejection sampling. So this has also not been used in ChatGPT. So this is the second thing. So these two are the major things that makes it different from ChatGPT. We will see what these are in the upcoming slides. So here I'll just give a brief overview each step. I'll also explain in the detail in the upcoming slides. So first, what we do is we get the pre-trained data. So whatever the complete data we have, we do is self-supervised learning. So this is the Llama 2 that we get. So we get the capability, because we take the internet as a whole of data, and we are using this self-supervised learning to make it learn. Now we have this LLM, and what we need to do is from this Llama 2, we need to make it into the Llama 2 chat. We need to be able to make it a conversational AI. So that is the alignment part. We have achieved the capability part, the alignment part. The alignment part is being done by two steps. The first is the supervised fine tuning, that we do here. The supervised fine tuning, what we do is we get human annotators to create prompts as well as prompts and the resultant generated answers, and we train on this as the first step. And once we get this, again, for the further alignment, what we do is we use this rejection sampling plus the proximal policy optimization to make it even more aligned to get the final Llama 2 chat. So this rejection sampling and proximal policy optimization is done with the help of this human preference data, where there is this set of annotators. They'll be given this Llama 2 chat, and they'll be making queries, and the answers for those queries, they need to rate it. For example, they give us a single query, and there are 5 different answers they get for the single query. So each of those answers, they need to rate it. This is very helpful. This is not that helpful. This is a moderately helpful, and that like they will make a rating, and they will make this rating both on the aspect of helpful. So whatever query they have made, how helpful is the answer, and whatever query that they have made, how safe is the answer. So whatever query that we make, it shouldn't give the answer. It should be able to analyze certain questions and not answer those. So whether the model has both these capabilities, they will be checking and giving ratings based on that. And based on those ratings, this rejection sampling and proximal policy optimization occurs. And finally, we get the final Llama 2 chat. So
See,
this is
PPO, we know PPO is a well-known RL algorithm.
yes,
Rejection sampling means what? It's an RL or it is just some custom process?
It's a custom process. I'll brief on that in the next slide, but it's nothing to do with RL. Like
And
it's
compared to Chat GPT training, here the human in the loop, you're saying there are two distinctions: safety rating and helpful rating.
yeah.
But you are saying in Chat GPT RL they didn't have these two.
No. At least they haven't mentioned actually. So
They haven't
they have been
described how they
they
exactly
haven't yeah, yeah.
this,
So
right?
we don't know, but here they have clearly mentioned that they have been using these
Okay.
two models.
Got it.
I have one question. Can
Right.
you explain what is the safety reward model and helpful reward model again? I
Yeah,
missed.
yeah. So, for example, the helpful reward model is, let's take, for example, we want to list out, we have, let's take, for example, I have a particular genre in which I like books. I need to rate the top 5 books that has been released this year on that genre. So I'll make up a prompt based on that, and I'll be getting answers. I'll get different answers based on the temperature. So the temperature of the model helps us in getting a different set of answers, and even the variance will give a different set of answers. So let's take, for example, for a given prompt, what is the top 5 answers that it's able to produce is what I'll be seeing. And the helpful reward here, my focus will be, so I have asked for 5 books. So is it able to answer those 5 books, and how relevant and correct is those? So based on that, I'll give the I'll check. So that's the helpful reward model. Safety reward model, for example, I ask the chat model how to create a bomb, for example. So it shouldn't answer it. It shouldn't make a detailed explanation of what are the components, different components in that. It should automatically recognize it's a violatory question, and it should answer. So that capability will be checked by this safety reward model. Yeah, so these are the things. Any other thoughts?
So Ashok, basically you're saying that it is kind of removing the hallucination kind of stuff, right?
Which one?
No, with this safety reward model, you are trying to be a little bit more accurate, right?
Safety, a little more cautious.
Cautious. Okay.
Yeah. These. Yeah. So in the further slides, I'll explain what are the different concepts used here. So the first thing that we have is this unsupervised learning or self-supervised learning. So that the pre-training of this Llama 2 that has been done through completely publicly available online sources. So we take the something like the open source data sets in the internet and we train it completely so that the Llama 2 gets the capability. So once it gets the capability, the next thing is the alignment. We need alignment because whatever prompts we give, the answer should be congruent. So what question we ask, it should make it in the conversation tone and answer it in the correct way. So that is done by these two processes. The first is the supervised fine tuning. Again, this is being done by the human annotators. They will be having a set of prompts and what is the answers that is expected. And with that, they will be fine tuning the model first. Once they have it, what they do is they again make it go through the reinforcement learning from human feedback. So this is done both by the rejection sampling and PPO. Another important thing is they have this iterative reward modeling. So they make it iterative, and they go through each versions and make it better and better.
For supervised fine tuning, the data is created by human annotation.
Yes.
The Y label is by human, but then it becomes human in the loop. So that becomes like more like RLHF. So even in supervised fine tuning, humans are involved, and RLHF also humans are involved, huh?
Yeah. So essentially, the Llama 2 chat, it needs two things. One is capability. The capability is like it needs all the knowledge. The alignment part is it should be able to answer in a correct way, whatever question we have. The capability part it gets by this unsupervised learning. So alignment, what are the different ways we can do? First is obviously supervised fine tuning. We have a data set, and with that we can make it align, and this helps it become even more aligned. The RL idea.
Right.
And then the next thing is they show what are the different model parameters. One of the interesting things is like if you see, it never saturates. The training loss for the models that is being trained, it never saturates. Even training on this 2 trillion tokens, we don't see any kind of saturation. So they have used like state-of-the-art GPUs, and they have used all of internet, but this not having any saturation shows that there is a lot more room for improvement in training this. So it could even more become aligned, and I think like further versions will make it better than this present version.
I have one question here. Why do we call it pre-training? Because we train this with completely supervised setup and then we will go for the RLHF. So that's the reason we call it pre-training, is it?
Yeah. So the pre-training is, the first thing what we do. This the first step is the pre-training. We just like take the all of the internet and train it now.
That is completely supervised setup, right? The first pre-training.
No, the first is completely unsupervised.
Okay, yeah, unsupervised.
Yeah. So that's where the pre-training happens, and that doesn't do any saturation. So that makes it like there's even more room for improvements. Is what this is showing.
I think the word pre-training is misleading. It's really first part of training, right? So.
So this is a distributional shift they have shown in paper, where like what are the different answers that it gives, and this is the first step after the unsupervised learning, how the answers are. And we after the annotation, if you see, it's more focused on here. And through several RL versions, we make it even more concentrated and aligned to what we expect it to answer. So that distribution shift is what they have shown here. The next thing is the rejection sampling. So the rejection sampling is an interesting idea. So what they do is they take the largest model. Here in this Llama 2 chat, the largest model is the 70 billion parameter model, and they provide a query prompt, and they get the answers. And in those answers, they take only the best answer, and they train this model and also the lower models. For example, let's take for example the 7 billion parameter model. These lower models also, they just train it. The RL algorithm is being applied only on this sample, not the all samples. So this essentially helps because this helps in kind of this knowledge distillation. The larger model capabilities is being given to the smaller one. So this is the main idea here. I'll just tell one more time. Like for example, we give this particular model a prompt, and this gives. Let's take for example, there's the generated response 1. There's a generated response 2. There's a generated response 3. There is 4 and 5. Let's take for example. So here in these generated responses, let's take for example, this fourth one is the most promising result that we have. So what we do in case of ChatGPT, what they would have done is they would take all these things. They have rated all these responses. For example, this would have got the highest score. These other 4 would have got lowest scores. All these scores with the highest and lowest is again being sent into the model for training. So here what they do is they just take this response alone. For this one, what is the loss? So that is what is being back propagated in the PPO model. So in this way, what happens is it becomes more fastly inclined towards the better response. Instead of training on both the good responses and bad responses, they just align towards the best responses and they train it on this. And that, because they do with first the 70 billion and make those losses back propagated to the smaller ones, they're able to distill the larger variance knowledge into the smaller variance models. So this is one of the interesting ideas they use.
It's like teacher-student network, right?
Yeah. The knowledge is, yeah.
What is meant by regression in some capabilities? You mean improvement in some capabilities?
Yeah, no. There has also been small deterioration. For example, I think what they have cited is the poetry kind of thing, which they were able to get it very good in the first versions, but the next versions didn't produce that good. So it could also lead to deterioration. But as a whole, what they have done is this rejection sampling has helped them a lot in making the fine tuning. And also the top performing samples, they just don't use the previous version. For example, the RLHF. Let's take for example, there are 5 versions. The 5th version is what they are fixing as the final model. So if there is V1, V2, V3, V4, V5, for the let's take for example, we have made this V1 model and V2 model. For the V3 model, they just don't use samples from V2. They also use samples from V1 and V2. So what are the different previous versions and what is the best answers in that they again use it. So in this way, also they try to make it more and more aligned. This is another idea they have used. So now we have seen the rejection sampling. We'll also see how is the reward model being trained with respect to PPO. So in the reward model, what is being done is they have over this 1 million binary comparisons. So what is binary comparison is where the human feedback comes in with the PPO. They give a single prompt and they get the binary responses. It could be with different temperatures or variance. They get different answers and they rate which answer is more suited for them and which is not. And this is being back propagated to the PPO. And this they do with respect to both the things. One is helpfulness, and another one is the safety. So as I told, helpfulness is how well the model response matches the user prompt. The second is if the response is safe or unsafe. So both this human annotators market for iteratively for these comparisons. So the reward modeling equation, what it essentially does is it checks for the given prompt, what is the preferred response. So this is the preferred response, and what is the rejected counterpart. So the binary comparison, they do it with what is the preferred response, what is the rejected response, and for that, what is the reward. And also they use this particular thing is like, for example, let's take for example, we give a x and it gives y1, y2 and y3. So there are three responses that it has given. And let's take for example, one of the key things that we need to understand is, let's say for example, these two are more close, and this is very dissimilar to whatever the query that we are given. So let's take for example, this is we give a score of 5, this we give a score of 4, this we give a score of only 1. So here if you see, these two are more aligned and this is very different. So that we need to take into account in the reward modeling equation. So that is where this comes into picture. This is the discrete function of preferred rating. So how much is the these two are different. So that is being taken into account with this. And we provide a sigmoid function log for the reward modeling. So we will be seeing how this reward is being sent into the PPU in the next slide. This is essentially what they do. They take the preferred output, the rejected output, and based on those rewards is what we use as the final reward for iteratively improving the PPO policy.
So sigmoid will create a binary classifier.
Yeah. Sigmoid,
So,
yeah.
okay, but inside of that you have this differential equation, reward of the desired YC and the rejected YR with a margin of M. So this is not classic logistic regression, but the sigmoid itself is a probability function. So it will give a probability of something, right? Sigmoid will give a probability of something.
Yeah. So this would be, yeah, would give values. This whole thing would give a values between 0 to 1, I think.
Correct. Sigmoid is a value, it's a probability. So it's always written 0 to 1.
Yeah.
But probability of what? In logistic regression is probability of the true class. Here is probability of what?
Sigmoid log, what? So why do they use this for the KL divergence essentially? So I'll tell in the next slides. But the KL divergence, it is of a similar thing. So they want to match the metrics, the values to be not very varied. They were not able to get some good results with that. That's why they use the sigmoid log.
Yeah, keep going.
So here, what they do is they don't. For example, how they could have gone through is they could have made it two different models. Like for example, PPO for the safety model is first they could have iterated over that, and they could have again iterated over the helpful reward model. So that is one way they could have gone. I think that didn't give them the expected results. So what they do is they take it as a hybrid reward model. So a single model, but it should cover both the safety and the helpfulness aspects of that. So that's how they do it. So here, if you see the reward, here if you see there are two cases. So if this is the case, take this. Otherwise, take this. They have a condition, and based on those conditions, they take either this reward or that reward. So that's how they go about this hybrid thing. So how they do is they take this threshold of 0.15 unsafe responses.
What is GNP and what is SNH?
Yeah, just let me. G and P. Okay, G is the generated response, and P is the prompt.
Okay.
We given a prompt, what is the generated response? And the first thing what we see is if the reward is 0.15 is whether it's safe or unsafe. When it becomes unsafe, we use this as safety reward. When the responses becomes safe, then we use the helpfulness reward.
Okay.
And that has been used here. So,
yeah. Okay.
Again, they again try to make this the final linear score with the logit and Voighton. So this is essentially reversing the sigmoid. So this is what I have been telling. Like why they do this final step is they want to achieve a greater stability and balance in the KL divergence. They use the KL divergence, which I'll show in the upcoming slide. So that this parameter should strike a balance between the next other parameter. So this parameter to have a more value in the range of here is why they use this Voighton logic. So I'll again tell it in the next slide why they do this. Yeah.
Just a quick question. So logit, I understand. What is this Voighton?
So this is what they told us is reversing the sigmoid. So whatever they do here, right, it's kind of the reverse of that. They use the logit, and Voighton is like what they tell is the reversing the sigmoid.
Okay. So one sigmoid on top of below one, you mean? One by sigmoid, something like that.
So PPO model, they explain how they use a PPO model. So it's the so PPO model essentially what it does is we have this policy and we need to do this policy optimization. PPO model ensures that it's a proximal policy. So why we need to be ensuring it is the policy that we learn new shouldn't be very offshoot, because when it becomes very offshoot, it could totally destabilize the model that we are trying, and that would not reach a good optimal policy. So that's why PPO is one of the key aspects in RL, because it helps in getting the optimize the policy quickly. So how it is able to do this? It tries to get the policy for this particular thing, the policy which is the pi with the maximum rewards for this particular generated response and prompt. So how do they improve the policy? So how do they improve the policies? First thing is they get the reward, and they get the KL divergence between the prior policy and this policy, and they compare and they use it to update this particular policy reward. So there is the prompt P, and there's the dataset D, and there's the generation G. What they essentially do is, so for the each iterative policy that they do, they have the scale divergence. This scale divergence, what it does is, it compares between the previous policy and this policy, and how different they are, and equates a value, and there's a penalty parameter. It is a penalty parameter, and this with the prior policy will give the updated reward. And this is how this is the reward equation that they use in optimizing the PPO.
I mean, this is classic PPO equations, right? Nothing different. Yeah.
Yeah.
Okay, so this is not. This was there before. It's very mature PPO, well-known algo.
Yeah. But one doubt I have, I don't have much clarity. One of the thing is that they don't use the KL divergence in PPO. So they use it in TRPO, the test region policy optimization, and then the PPO, what it does is, it made as a simple ratio in PPO. But here in this paper, they have described it as a KL divergence. So it's not sure how it's a KL divergence equation.
Mm-hmm.
So this one doubt even I have. But essentially, the PPO policy is what they use in the ChatGPT here too. How they use is like the responses, they make it even more aligned with the help of the rejection sampling.
Yeah, creating these models is all mathematical innovation. So
Yeah.
they have PhDs, in machine learning and maths and statistics, who keep manipulating these algos, trying to get better models.
Two main ideas here is, the first thing is, so these are the two main ideas, because ChatGPT, they haven't revealed much about the PPO. Here they have even more like specifically how they are designing the reward function is what they have explained. The first key thing here is they use this binary comparison. So each given query, they get the two responses, and there's a preferred response, rejected response. Both go into this picture of reward. So that is one of the key aspects to keep in mind. The second thing is the hybrid model. So the reward function in itself is a hybrid model, where it takes into account both the safety aspect and the helpfulness aspect. So these two are the main things to keep in mind while coming to the RL part of it.
See, one more way to do this previous one would have been to do a cumulative weighted reward function, like
Yes.
alpha of RS plus beta of RH.
Yeah. There could be multiple ways it could be done. First, it could have been aligned with the safety and helpfulness. Yeah, even the weighted thing. I think they would have tried all those ways and picked which one is giving them the best.
Yeah.
This is about the RL part. If you guys have any doubt, please to ask. This is the final thing. I'll also tell about the benchmarks. So benchmarks, what they have combined, compared in the paper is, so there is several things. For example, this MMLU, this is the language, massive language understanding, I think. And trivia Q&A is like question and answering. Natural questions is like you just Google something like what it is about, and it should give some answer, right? So those kind of data sets. And here this human eval, AG eval, these are like I think coding questions are also combined. And here this AG eval is like you ask some questions and English tag, and whether it's able to answer. This is Bool Q. Here it's a binary answer. So you ask a question whether it's able to tell a yes or no. So these kind of open source data sets they have, and they have tried benchmarking how much is the previous open source models have given and what this model is able to answer it. So this is what they have given. And here if we see, there is this MPT. So MPT is the model that has been released by this Mosaic ML, and they have been backed by Databricks. So that is one of the things. And this Falcon is by I think Middle East from release Falcon. These are two of the most famous open source models before, and now open source. I think Llama 2 is the one that has been most preferred, and you can see that compared to the previous things benchmarks, it has significantly able to make better results. So in each of the aspects. So these aspects is essentially if we are able to reading the comprehending what we ask and whether it's able to answer it. English task, coding questions, on all those aspects is being rated, and you can see that in each of those things, the Llama 2 is able to outperform both this MPT and Falcon. The next thing is this helpfulness human evaluation. Again, what they do is they compare. Let's take for example, they take the Llama 2 and the variant. Here it's the 70 billion variant, and they compare it with this Chat GPT and see whether the helpfulness is whether it's able to win it. Win essentially is like Llama 2 answers is better than the Chat GPT. The tie is it's almost same. So that is the tie, and it's losing when Chat GPT gives a better result. That's what they have been trying to address here. So here we can see that almost if you add the win and tie, it's 68, 69%. So almost 70%. It's on par with ChatGPT. This Palm Bison, I think, is by Google. So again, here if you see, it's almost 80% it's able to give it. Again, Falcon is what we saw in the previous slide, able to give even 90%. And there's this Vicuna. So Vicuna is interesting because what they did in this model is there is there's this Chat GPT where they post questions which they find to be very weird with Chat GPT. So that is being created as a data set as a whole, and that has been trained on a Llama version 1. So that is this Vicuna, and with that they have comparing. So that is the Llama 2 and Vicuna. And again, with the MPT they are trained. So you can see that it's almost 70 to 80%. It's helpful, and it's even more impressive with Chat GPT because it's a closed source price model. It's a completely free model, Llama 2. The next thing is, like as we saw, based on the helpfulness, again, this is see based on safety too. So how much is the violation percentage is what they see here. So they see that, yeah. We can see that it's almost comparable with Chat GPT, while all the open source models like MPT, Falcon, Palm Bison, Vicuna, they have huge violation rates. But here we can see that Llama is even more like better than even Chat GPT while comparing the safety aspect of the model.
So here you're referring to GPT-4, Gautam?
I think they have made 3.5. I think. So this is the safety human regulation. The final thing is this LoRa. So what it means is quantized LLMs with low rank adapters is what this LoRa is about. Why this is important is like we have standardly how we train is how we could not fine tune these models because we have a limited space of GPUs, and when we need to fine tune, we would not be able to fine tune on this massive model with the GPUs that we have that would typically be available to us. So to get around this problem, what they did is they used this LoRa, this kind of the version 1, and this is QLoRa, the version 2. So what they do is they use this thing called adapters. So whatever the model is being split into two weight matrices. One is the original weight, and the second is the weights to be updated. So this weights to be updated is again being classified into paths, and this path is only being used as a in-memory weight that needs to be updated. Again, that they make it even more better with this bit quantization, and that's how the version 2 is. So essentially, why this QLoRa is important is we need for the fine tuning a GPU optimization that we are able to achieve with QLoRa. So this is important with respect to fine tuning. I'll make the conclusions and then brief on the code that is which we can use to generate responses. So Llama 2 is a very important model because it's a very open source model, and it helps in fine tuning and having more control over how we need to design our product compared to closed source models like ChatGPT. So that's why it is very useful. And some of the key concepts that we saw is it uses rejection sampling and reward based on both the helpfulness aspect and the safety aspect. And as we saw in the training losses, it never saturates, and they have also been trying with other methods. Is what they have discussed in the paper. So with scope for more improvement, I think the Llama with the future versions would make like more transparency and safety in the field of LLMs. So this is the key aspect of Llama 2. I'll also show the code that could be used here.
Gautam, I just have a quick question. This is about QLoRa. So what's the major difference between LoRa and QLoRa here?
QLoRa, so I haven't seen much on this. Probably I can take a webinar in the future things discussing each of the mathematical concept here. QLoRa, it essentially is like, if you see here, the model is 16-bit and 4-bit. The bit optimization is also being done. So it's kind of a successive version that makes this fine tuning a lot better with respect to LLM model.
Okay.
Yeah, in the previous webinar, I remember the presenter said QLoRa means we convert to 4-bit parameters temporarily for fine tuning, then bring it back to 16-bit, something like that. So it helps in reducing memory requirements and optimized fine tuning.
Yeah, so that's that I saw in the fine tuning part in the Llama. So that's I added a brief intro on that in PPT.
Okay. And Vivek, I have one more question. I mean, not a question, probably just a clarification. When we were talking about the PPO model, you had mentioned that they could have used weighted averages and then done the, uh, safety and helpfulness reward comparison, right?
Mm-hmm.
So, but when it is already getting ranked and based on the ranking is how they are picking the comparison, binary comparison. So, isn't the weighted average calculated there itself? Or did you mean anything else? Did I
No, I
misunderstand?
meant sometimes what you do when you have conflicting optimization function, right? So which either you can achieve or that, but not together. What we do, we created a weighted cumulative loss function. So since there was two sort of rewards, one was safety reward, the other was helpfulness reward. What we could do, and they were trying to decide which of the two to use. We could combine them in a cumulative reward function in a weighted way. So using alpha beta control parameters, we could. So that
Okay.
is often used in conflicting, optimization to create a cumulative reward.
Right, right, right.
That
But
is
over here, when they
what we
use
are discussing
safety
here.
reward, yeah, sorry. Here, when they use safety reward, it was more for responsible AI purpose, if I'm right, right?
That's correct. Safety is about guardrails, whereas helpfulness is about is it good answer or bad answer.
Yeah, to improvise their model, while safety is for responsible. Yeah,
Correct.
got
That's right.
it.
So Llama 2, essentially here, if you see, there's a repo they have given, the Llama 2 that they have released. We make a CMake and we tell what is the model path. So here what we use is the Hugging Face. So Hugging Face has the support. So there we take the Llama 2, what is the model and what is the particular format that we need. And then we initialize that particular model. And here, if you see again, here this is the thing where we tell for the Llama how to use the GPU, what is the best optimized method. So since I ran the Llama in Llama V2 in Collab, so that what are the specs that we could be using? So all those particular things I have mentioned that. For example, the number of threads, the CPU cores available is 2, and this batch is the 512, and the GPU layers that is available there again, that is 32. So that is being used in the Llama, and so here we can see that the GPU layers to be used is this 32. So we specify how the GPU is to be used in Llama. Then what we do is we create the prompt. So here the example prompt is like write a linear regression in Python. And the prompt template, how to give the template is what they have given. So we have given you like how they have trained it. So your assistant always answer helpfully. And what is the user prompt? So this prompt is what it will take in. And the assistant, what is the response to be given? So, and we invoke the function. So the function that we invoke, it has several parameters, and these parameters needs to be given according to the answers that we need. For example, the prompt first is in the prompt. Prompt template is what we see here. So this is a template that we use. Maximum tokens. So here what we do is the answer, how many tokens maximum it can have. So whether we need a short answer or a very brief answer, based on that, we can specify what is the maximum number of tokens to be given. The next thing that we use is the temperature. Temperature is like it varies between 0 to 1. 0 between the most the one that gives the highest probability that to give us the response. As we go with higher and higher values, it gives more creative answers for the prompts that we give. And the next thing is the top probability. So the top probability is like we could have different responses. So which response to bring? If the response has at least a probability that's greater than 0.95, that is the thing to be taken. And the top K, the first among the first 150 results, and the repeat penalty, if the answer has repeating tokens, the penalty to be given that. So these are the things that we have given. And once we have given, we can generate the response here. So here, if you see, we just print out the top choice that it gives. We can see that the assistant has given that to create that linear regression. We use the scikit library. We use the scikit and that we read the file, the linear regression coefficient, what is the x values, what is the y value, and what is the predicted things. So it's able to produce the code. This is how we can be able to create responses with respect to Llama 2.
Why are we doing linear regression here? I didn't get that part.
No, it's just like a query. So we are given that write a linear regression in Python.
Oh, okay. It writes code for you, okay.
Yes, yeah. Able to write those code. I even tried, I think, another. Okay, I have given that list down the best comedy movies released in this decade, and I've asked it very similar code. It's able to tell, like, because of the tokens, it stops at this thing, particularly here without describing these things, because our context length stops there. But we can see that it's able to tell like hangover, super bad, right, heat, 21 Jump Street. So it's able to list down the best comedy movies.
What is the second notebook you are showing compared to first one?
So first one was a code program. So I tried for this, the query is like list down the best comedy movies. It's able to give that as that.
So second notebook is just trying it.
Yeah. So this is about the Llama 2. So in this way, we can be able to make it like run locally and use it like product compatibility. So ChatGPT, we need a key and it would invoke the model there, but here we can download the model locally and use it. We don't need any internet connection. This particularly is very helpful where we don't need a data breach or something, and we are not sure about it.
No, for Chat Llama 2 or Llama Chat,
Yeah.
there is no UI available, right? I mean, we have Freedom GPT for our client, but apart from that, there is no Chat GPT style UI available for Llama 2 Chat. Is there?
No. We can build. Yeah. They have given the model, so we can be making it also.
Gautam, I have one question.
Right.
So is LangChain, have you tried using LangChain along with it? Have you tried that as well? How well does LangChain framework support Llama 2?
I haven't used it, so I'm not very sure on that. I've seen like many projects, so it should be pretty compatible, is what I think. But I haven't tried it. Yeah.
Okay. And then just one more question. I think recently, 2 days ago, they released Llama Code, Llama Python, and Llama Instruct. So, are they divisions of Llama 2 just specialized on each of that particular field, or you can find them in this Llama 2 model itself combined, or are they different models?
I think they have released those as like since they have released this, they have fine-tuned on that particularly. For example, the Llama code on those code examples and made it better and released that as a separate version.
Okay, so again, I have to download Llama code if I want to use a domain-specific.
Yes, yeah. So this in itself will give the code examples, but yeah, obviously they would be a lot more better. So the fine-tuning part, how it is being done here is like Hugging Face has great compatibility with that. That is what it is being used here. So what we do is, like again, from transformers, we import what are the functions that is being required. And here, how do we need to train it? What is the model name? What is the data set name? So which data set we need to fine tune it on? And So here, as we can see, they use this QLoRa parameters because uh, with this, with the limited GPU capabilities we have, the fine tuning is a big task because as I used the T4, it was not training on T4. It crashed. I think even more bigger than T4 is what we needed. But even with that bigger than T4, we need this QLoRa to make it optimized for that fine tuning. So we input the QLoRa parameters, and after that, we specify what is the sequence length, the checkpoints we created, all those hyperparameters. So once that we do, we load the data set, we tokenize, and we make the model compatible with the QLoRa configuration. So once we have that, we see the GPU compatibility, and then we take the model, we take the pre-trained Llama model, and we take specify what is the quantization configuration we have. And once we have this, we again load the Llama tokenizer, the LoRa configuration, and then all the training parameters, very similar to the ones that we use in Hugging Face. And then we make the supervised fine tuning that we saw as such, and we'll be able to train it and save the model. So this is the example of how we can fine tune.
Where is the supervised data? For supervised fine tuning, you need supervised data. Where is that?
Yeah. So here they use a specific thing where they ask in a specific language, and I think it gives in a different answer in a specific language. So that is what they have trained it on. So what is the data set that we need? We can accordingly fine tune on that. Here, this is the data set they have used for the fine tune.
Oh, this Guanco is a Q&A data set, right? So it already has Q questions and answers. Okay.
Yeah.
Using this, they have fine-tuned in a supervised manner.
Yeah. So here, as I said, like it answers in a different language. So that is not some capability that Llama presently has. So this fine tuning will be able to achieve why they are training this particular data set.
So Llama 2 does not support for translation. Like, what are the languages currently? Only English, is it?
I think it's only English.
And also, it's not a multi-model, right? It's only for chat currently.
Yeah, it's chat. Yeah.
And here, when you say fine tune, are you kind of freezing some layers and tuning it, or how is it like?
Yeah. It's fine tuned because we have the model. We are just fine tuning on this particular data set to achieve good results on this. So that's why the fine tuning part comes in. This is very important because, like for example, in practical applications, let's take for example, we build a product. Medical journal could be a good example that we need to make a chatbot that's very compatible with that. If we have a closed source model, we would not be able to make it more seamless, the chatbot, because that may not be trained on those medical terminologies, and we could not make a very optimized chatbot. But here, when it is an open source model, we can just train that on this particular data set that we create with this medical journal and fine tune on that so that we will make.
No, I got it. So basically, when you say when you do fine tuning, right? So do you freeze some layers and then start doing it like transfer learning, or how do you do that?
The freezing happens here because we could not use that big a GPU for training the model. So we use only part of this model weight and train it on it. So that is done, but the fine tuning as such is being done on the whole model.
Okay.
So Suresh, in fine tuning, they usually reweight the update the weights. So then all the layers will be used. Only if you're model is learning on custom data, then you will freeze most of the layers and use only last few layers. But in fine tuning, you can
You do
use
the
all the
whole
layers.
model. Okay. Not like transfer learning where you freeze certain things and make it available for some other tasks also, right? Okay, okay. Right? That's what you're saying, Krishna, right?
Yes, yes, exactly.
Okay, whole data you again retrieve with that. Okay, got it. Yeah, thank you.
Yeah, so these are the codes based on like running the Llama V2 and fine tuning it on. So if you guys have any doubts,
Any questions, folks?
So for fine tuning, I think you're using the because you're using the QLoRa or LoRa based one, so that it can be run on a single GPU or a couple of GPUs, right?
yeah,
Okay. So in the Colab on a free version, is it allowing us to fine tune?
no, no. The maximum the free version allows is the T4. I tried it on T4, it's not working. We need a paid version.
Okay.
So
Did
where
we?
did you run it then, Gouthaman? Sorry.
So the fine tuning part, I wasn't able to do it actually.
Okay.
I was showing the code, but yeah, it crashed at the fine tuning. They were able to do the higher versions in the collab actually.
Sorry,
This-
Prasanna, you were saying?
No, it's the same. I think can we use the free version of the Colab for fine tuning it? I think I got the answer. It is not possible. Probably, we may need a paid version to actually fine tune that one.
yeah.
So we have Gamma GPU TR and Cellstrat Hub. It can be used by our community members who are doing serious product development. So that should be possible. So good presentation, Gouthaman. Any other questions, audience?
Vivek, can we get these slides or something from Gautam?
I mean, that's up to Gouthaman. This is not our product-centric presentation, so we are okay. Is Gouthaman's stuff?
Yeah.
It's up to him.
Yeah, I can share it.
Yeah, and some article probably related to rotating motion, rotating position embedding part. That part was a bit.
Yeah. So the rotated proportional embeddings, I think paper with code, it has the concept with the paper.
Shruti, you go and ask Bard, it will explain you. So Gautam, we'll be sharing the link here in the chat, the slides and all.
Slides. Yeah, sure. I have in the local. I'll upload and probably post a link or something.
Where will you post in the meetup?
WhatsApp group.
Yeah, you can put it in AI Lab, Global AI Lab group.
Okay, sure.
Okay.
Problem with all of this generative AI domains is this area is moving at a blinding pace. By next week, so many new things are in town. So it's really hard to keep pace and learn. So it's moving at a blinding pace, driven by big tech companies, of course. So all we can do is, as a community, just keep learning and keep teaching each other through these presentations.
Yeah. True.
Any other questions, audience? So as I said, thanks, Gouthaman. Fantastic presentation, very detailed. Those who want to work with Cellstrat product team, contact me. So well done, Gouthaman. Thank you.
Yeah. Thanks, guys. Thanks.
Thank you. Very nice, Gautam. Thank you.
Thanks.